tend to think of Seth as Carl Sagan with a better sense of humor. And that's not to say anything bad about Carl, because Carl was on our board of trustees until his death, and a good friend. But Seth has an extraordinary way of educating the general public about very complex science. If you have not had an opportunity to listen to the SETI Institute's radio show, Are We Alone? I commend that to you. Seth and his team produce a new radio show weekly. You can find it on our website. Right on the homepage you'll find a link. There's a podcast and many other mechanisms to download it. And I really commend that to you. So now I'll add a little bit of formal introduction. Seth, as you know, or probably know, appears very often on television. You will see him on the History Channel, National Geographic Channel, the Larry King Show, and many other places. Seth claims to have developed an interest in extraterrestrial life at the tender age of 10 when he first picked up a book about the solar system. This innocent beginning eventually led to a degree in radio astronomy, and now as senior astronomer, Seth is an enthusiastic participant in the Institute's SETI observing programs. He also heads up the International Academy of Astronautics SETI Permanent Study Group. In addition, Seth is keen on outreach activities, interesting the public, and especially young people in science in general and astrobiology in particular. He's co-authored a college textbook on astrobiology, continues to write trade books on SETI. His most recent book, which is entitled Confessions of an Alien Hunter. Yes. It's a beautiful book, actually. Is available in the lobby today during the intermission, and Seth would be happy to autograph that for you. In addition, Seth has published nearly 300 popular and professional articles on science. He gives many dozens of talks annually, and as I said, is the host of the SETI Institute's radio show. So without further ado, it's my pleasure to introduce Dr. Seth Shostak.
There he is. Well,
Thank you very much, Tom. That introduction was more than I deserved. Always bad news for a speaker to get a very florid introduction because you can never live up to it. It's better that they say, you know, we really didn't want him to talk, but here he is anyway. After that wonderful talk by Doug, with lots and lots of data, I'm going to talk about a subject for which we actually have no data. So, no data, but so this is a speculative talk, and its purpose is mostly to provoke you. I hope it will. Maybe it'll stimulate you to think about this a little bit, because these are some things that I suspect a lot of people haven't thought very much about. What will the real ET be like, and why do you care anyhow, right, if you're just looking for them? Now, here's a picture of a guy who's in the back of the audience, posing here next to the 85-foot Howard Tattle Memorial Telescope in lovely Green Bank, West Virginia. Frank Drake did the first SETI experiment back in 1960. I think most of you are aware of that. And he used this instrument for, I think it was 2 weeks, right, Frank? And pointed at a couple of nearby stars. Didn't hear anything. Actually, that's not true. He did hear something, but apparently that was military aircraft, which doesn't count as extraterrestrial intelligence. But that was the beginning of SETI, okay? And we haven't heard anything so far. Actually, nothing that's confirmed. We get signals all the time. People often will ask about the WOW signal and other well-known signals that we picked up and didn't know what they were. And you can't, let me just put my watch down here so I have some idea of the time. You can't rule those out. I mean, the WOW signal, which was, what, 1977, appeared once, and only once. It's been looked at again many times with higher sensitivity and greater spectral resolution and never seen again. But then again, it could have been ET, and then ET got bored as soon as it sent the signal and went on vacation, and that's why we haven't heard anything. But that's not science to make that claim. It sounds interesting, but it's not science. So we've not found any confirmed signals. But one, people will often ask, well, after 50 years, don't you think that, maybe you're barking up the wrong arboreal fixture? Maybe this isn't the way to do it. I mean, if you haven't found anything in 50 years, you think of most exploratory programs, particularly those of the 16th century. And although they would take a long time, they usually didn't take 50 years. There are some exceptions. Finding the Northwest Passage took longer than 50 years. Finding Antarctica took longer than 50 years. I think that the reason we haven't found it is not, it doesn't say anything about the prevalence of extraterrestrials. It does say something about the degree with which we've been able to pursue the experiment. For almost all that time, most SETI experiments have been performed on somebody else's antenna. This is, of course, the Arecibo telescope down in Puerto Rico. How many of you have seen this, by the way? Actually visited it. Well, that's good. This is, of course, a self-selected crowd, but you should go see it if you haven't. You know, you go to San Juan and rent a car, and it takes you an hour and 20 minutes to drive up to the observatory. There is some threat to this telescope. Some of you may be aware of that. The National Science Foundation has essentially told those who operate the telescope that they have a few years in which to find additional funding. Otherwise, the whole thing may be unbolted and trucked away. So I would recommend that you take a look at it if you can. But the point is, we've only occasionally listened. And I liken this to trying to do cancer research, but always having to borrow a microscope. It's no way to do it. You only get the microscope a couple of weeks a year, which is the approximately correct fraction of time that we've had on, for example, this antenna. So what this all means is that the number of star systems that have been looked at carefully by SETI researchers is very small. It's like 750. And you really wouldn't expect to have success when you've only looked at fewer than 1,000 stars in the galaxy. So the fact that we haven't found anything so far is not, in my mind, at all significant. I show this picture because many of you have seen this movie. The SETI Institute, by the way, was a consultant for this film. And we told them that this was wrong because Jody's only monitoring 2 channels, and at the time we were monitoring 56 million. So I mentioned to Warner Brothers they should put 28 million pairs of earphones on Jody, which they declined to do, saying it would crowd the shot. This is not what it looks like, of course, and this would be really a very tedious operation if you had to analyze the data this way. I mean, you would get really bored after about a week, probably after about 10 minutes. It actually looks like this. I show this photo a lot because it took some time to make this photo, actually. This is down in Arecibo. So this photo is about a decade old, but you can see the workstations there. Of course, the data reduction is all done by computers. And in fact, the idea is to get that carbon-based life form out of the picture. At the time in Arecibo, Arecibo observing time is, of course, so valuable that we would actually go down there and sit at the telescope and babysit the system, because the system is a one-off system. So the hardware and the software occasionally have a glitch and you have to restart it. Most of the time, of course, it works, and you sit there filling in the logbook and making self-portraits like this one. But the new systems are fully automated, and they should be fully automated, in fact. Now, once again, I show this slide a lot, and it's only designed to tell you what it is that we look for, because people will often ask, are you looking for the value of pi? Or if they're Dan Brown fans, they'll say, what about the Fibonacci series? Isn't that what they'll send us? That sort of thing. We don't look for any of that. We're not looking for patterns, right? I mean, we look for very simple patterns, a repeated signal that pulses on a regular basis every couple of seconds. We have receivers that will find that. But in general, all we look for is some spike in the radio noise entering the receiver. In other words, what's called a narrowband signal. And you can see lots of them here. And they all look very promising, but unfortunately, these are all terrestrial interference. This is, radars down the north side of the island, or mostly telecommunications, satellites, and things like that. So that's what we look for, just a narrowband signal, because as far as we know, nature doesn't make signals like that. Quasars, pulsars, they all make lots of radio waves. Hot gas, cold gas, all makes lots of radio, but it's not narrowband like that, right? And if this seems perplexing to you, consider what happens when you're driving around listening to your car radio during a lightning storm. Right? You'll see the flash of lightning, and you'll hear the crackle on your AM radio, no matter where you're tuned. It doesn't matter what station you're listening to, whether it's like country and western station or whatever, classical, whatever. You'll hear it everywhere, because the lightning bolt, that's a natural phenomenon, and it makes electromagnetic radiation all over the spectrum. You can see it with your eye, right? That's the lightning bolt. And you can pick it up on the radio too. That's, pretty far down the spectrum. Okay. So natural phenomena make radio noise all over the band, but what we look for are signals that are at one spot on the dial, because that's a transmitter. As far as we know, that's a transmitter. If we were to find something like this and it turns out to be a natural phenomenon, well, at least you get the Nobel Prize, which is something as compensation for not having found ET. At least you found something new in astrophysics. Okay, so that's what we do. And if you were to find something like this, of course, I think the funding problems that SETI perennially